Hey everybody, welcome back. We are here today to talk about polynomials, and this is an introduction to what they are. Let's begin by talking about a term. Terms are things that are multiplied together. Well, if they're multiplied together, then that means addition, subtractions, and equal signs separate them.
This expression right here is two terms because the plus separates the terms. The plus and the minus separate the terms here, so there are three terms. This is only one term because there's no plus or minus. And this last expression is four terms because the pluses and the minus separate the terms into four terms.
Hey, this is math class and we do problems. If I talk about number one or number two or number whatever, I'm talking about the number in the upper left-hand corner at Socrative. This expression may or may not be polynomial. Either way, how many terms is it? It's a bunch of terms. This plus, this minus, this plus, and this minus. Separate them. There are 1, 2, 3, 4, and 5 terms. The answer is 5. Number 2 is the same game that we like to play. There's only one plus sign right here, so there's only 2 terms. Let's define what a polynomial is. That's what we're here to do. It's a mathematical expression that contains algebraic terms with whole number exponents and no division of variables. And a monomial is about the same thing, it's just that it only has one term. You may want to pause the video and look at some of these examples. They are all either a monomial or a polynomial. Let's focus on some of these. These are not polynomial. Let's go back and look at the definition. Polynomials have to have whole number exponents. -1 is not a whole number, and neither is -3. That right there is understood to be x to the 1/2 power, and 1/2 is not a whole number. You can have no division of variables in a polynomial. That's why that's not polynomial. The terms need to be algebraic, not trigonometric, so cosine is not polynomial. Absolute value is not polynomial. The natural log is not polynomial. The exponent cannot be a variable. That's not polynomial. Number 3 makes me smile. How many of the following equations are polynomial? We cannot have a variable on the bottom, so we would strike this one, and this one. This x is understood to be on top with the 1. Absolute value is not polynomial. Square roots and cube roots are not polynomial. Sine, cosine, and tangent isn't polynomial. This equation is the only one that is polynomial. The answer to number 3 is 1.
Number 3 was so much fun. Let's do number 4. It's the same thing. Let's eliminate division of variables. Absolute value here and here. Neither sine nor square root is polynomial. All three of these are polynomial. So the answer to number 4 is 3.
Let's talk about some special names of polynomials. All of these are binomials because they're polynomial with 2 terms. You know, like a bicycle has 2 wheels, a binomial has 2 terms. Same thing for a trinomial. A polynomial with 3 terms is called a trinomial. You know, like a tricycle has 3 wheels, a trinomial has 3 terms. After that, there's not really any special names. A 4-term polynomial is just called a 4-term polynomial, and so forth and so on. Number 5, what is the best name for the following? We want to start with E and ask ourselves, is this expression polynomial? And the answer is yes, so we do not put E. And since it's 2 terms, we say it's binomial. Number 6 is the same thing. Since this expression is polynomial, we eliminate E. We should understand there are 1, 2, 3 terms. The answer is trinomial C. Number 7, we should start with E. Is this a polynomial? And the answer is no, because -3 is not a whole number. Therefore, the answer to number 7 is E. We now know what a polynomial is. Let's expand on that. If an equation or an expression is either monomial or polynomial, then it has a degree. All of these are either polynomial or monomial, and they have a degree. These over here, though, are not polynomial, and they do not have a degree. Let's deal with monomials first. The degree of a monomial is the sum of the exponents of the variables that appear in it. If a monomial is a single variable, it's just the exponent. You should know there are 2 x's there, so the degree is 2. There's 1 x here, there's 5 x's there, and there's 4 x's there. So those degrees are 1, 5, and 4. If a monomial is multivariate, though, we have to add the exponents. You might be thinking, multivariate, what kind of word is that? That just means more than one variable. In this monomial, there's 1 x and 1 y. You add them together, the degree is 2. This monomial has 2 x's and 3 y's. The degree is 5. This one has 2 x's, 2 y's, and 5 z's. The degree is 9. Finally, this one has 1 x, 1 y, and 4 z's. That is degree 6. In a problem like number 8, we want to start with G where it says it is not nomial. As a refresher, nomial means it's going to have whole number exponents, no division of variables, and algebraic terms. Yes, this is nomial. The answer is not G. Since this monomial is of a single variable, it's the exponent 2. Number 9 is understood to be 2x to the 0 power. It is nomial, so the answer is not G. The degree is the power of the exponent, which is 0. Number 10 is not G. It is nomial. There are 2 x's here and 3 y's there. That's a total of 5 variables. The degree is 5. And number 11, we should know that -2 is not a whole number. So number 11 is choice G. We cannot use the suffix nomial. Now let's talk about the degree of a polynomial. It is the degree of the term with the largest degree. Let's talk about single variable polynomials first. You want to do the degree of each term one at a time. The degree of this term is 4. The degree of this term is 3. The degree of this term is 0. The highest degree term was that one. The degree is 4. You might be thinking, hey, the answer was the largest exponent. And when it's single variable, you're right. Let's still spotlight some terms, though. The degree of this term is 1. The degree of this term is 0. The degree of this term is 2. The term with the biggest degree was 2. The answer is 2. I think we can see in this one the answer is 8.
And in the bottom polynomial, the term with the largest degree is 3.
Be careful, though. Multivariate polynomials are a little bit different. We now know the degree of this term is 3 because there are 2 x's and 1 y. And the degree of this term is 1. The term with the biggest degree was 3, so the degree of the whole polynomial is 3. You might be thinking, wait a minute, the answer was not the largest exponent, and you know what? You're right. Let's keep the spotlight going. The degree of this term is 2, the degree of this term is 3, and the degree of this term is 6. Therefore, the degree of the whole thing is 6. Let's go without the spotlight. The degree of this term is 6. The degree of this term is 4 plus 5 plus 3, which is 12. The degree of that term is 1. The degree of the whole thing is 12. Last polynomial, the degree of this term is 2, and the degree of that term is 0. The biggest one is 2.
Number 12 says, what is the degree of the following polynomial? We want to start with G and ask ourselves, is it nomial? It is because it has whole number exponents, no division of variables, and its terms are algebraic. Let's do the degree one term at a time. The degree here is 3, and the degree here is 4. The term with the biggest degree is 4. The answer's F. Number 13 makes me sad because it's not polynomial. We can't have division of a variable. The answer is G. Number 14 is multivariate, which makes me nervous. We can do it, though. Let's do the degree one at a time. The degree there is 8. And the degree of this term is 10 plus 10, which is 20. The term with the biggest degree is 20. The answer is C. Number 15 is not fair. There are 3 columns, and we have to pick an answer from each column. We should be very aware that that's a polynomial, so in the first column, we are going to choose B. We can count terms, 1, 2, 3, 4 terms E, and the term with the biggest degree is right here, 6. At Socrative, you have to put in all 3 choices to get number 15 right. Man, I love 3 columns. Here's another one. You should recognize square root as not polynomial. So we have to put choice A. Even though it's not polynomial, it still has terms separated by the plus and the minus. There are 1, 2, 3 of them. But when something's not polynomial, the answer in column 3 is always J, because things that are not polynomial don't have a degree.
Before we go, let's talk about special coefficients of polynomials. Let's talk about lead coefficients, quadratic coefficients, linear coefficients, and constant coefficients. The lead coefficient is the coefficient of the term with the largest degree. In this top polynomial, the lead coefficient is -7. In this blue polynomial, the lead coefficient is +1. In this green polynomial, the lead coefficient is -9. And lastly, down here, the lead coefficient is -5. A term of degree 2 is called a quadratic term. Therefore, the coefficient is called the quadratic coefficient. The quadratic coefficient right here is +1. In this polynomial, it's -7. This polynomial right here makes me sad because it doesn't have a quadratic term, so its quadratic coefficient is 0. I really like this polynomial. Its lead coefficient and its quadratic coefficient is -5. A term of degree 1 is called linear. Therefore, the coefficient is called the linear coefficient. This top polynomial is also sad. It doesn't have a linear coefficient. It's 0. This one has a linear coefficient of 10. This one has a linear coefficient of 5. And the linear coefficient here is positive 8. A term of degree 0 is called a constant term. Therefore, the coefficient is called the constant coefficient. The constant coefficient here is 10. Constant coefficient is negative 17 here. This polynomial's not in standard form. Its constant is 3. And finally, this one has a constant coefficient of negative 4. Number 17 is true or false. The linear coefficient of the polynomial is negative 7. Let's put in all our names. The lead coefficient is 4. The quadratic coefficient is negative 7. The linear coefficient is 5. And the constant is negative 3. Number 17 is false. Number 18 says the quadratic coefficient of the polynomial is 8. Let's see, the lead is 10. The quadratic is 8. The linear is negative 1. And the constant is 2. This one is true. Number 19, let's name the coefficients. The linear is 5. The lead is 9. The quadratic is negative 4. And the constant is negative 3. This one says the constant is 5. Clearly, this one is false. We've named the 4 special coefficients in number 20. The problem says the lead coefficient is 10. Nope, it's negative 9. Number 20 is false. In number 21, it says which polynomial has a linear coefficient of 2. Let's identify all the linear coefficients. 7 here, 5 here, 5 here, 2 there, and 3 here. D is the answer. Number 22 looks similar. Which polynomial has a quadratic coefficient of negative 1? E doesn't have one. D's quadratic coefficient is negative 3. It's positive 2 here, positive 5 there, and negative 1 here. Choice A is the answer. Number 23 and last problem of the day, which really makes me sad because I'm going to miss everybody. How many of the following expressions are polynomial with a quadratic coefficient of negative 4? Let's eliminate anything that's not polynomial. Negative 5 is not a whole number. It's an integer. This is not polynomial. Polynomials do not contain division of variables. Square roots are not polynomial. And neither are trig functions like cosine. The rest are polynomial, but this one has a quadratic coefficient of 19. The rest of these are good because they are polynomial and have a quadratic coefficient of negative 4. The answer to number 23 is 3. Everybody, I had a whole lot of fun today talking about polynomials, degree, and special coefficients. I can't wait to see you next time.